Okay, let's talk about speed. More specifically, average speed and instantaneous speed. Okay, what is average speed? Well, average and instantaneous speed. Average speed is speed over a given interval to find average. For instance, if I were to, let's say we had a distance equation of a falling rock, right? And that it would be 16, y is equal to 16 times t power of 2, where t is time, the time it has been since the rock went from a resting state to a falling state. And this will give you the distance it has traveled. Now, if we wanted to find the average distance, what we'd have to do is find change in y, the average speed, the average speed, because this would be the change in y, the distance, change in distance, over the change in time. That gives us the speed of the rock. And in this case, it would be 16. Let's say we were to do it over 2 seconds, minus 16 from the point that where it started, which was 0 seconds, it was falling for 0 seconds, over the change in time, which is 2 minus 0. Because it went from a rest state of 0 seconds, would point it wasn't falling at all, to it had been falling for 2 seconds. So if we do this calculations and stuff, this would be 64 minus, this would be 64 minus 0, which would be 64 over 2 minus 0, which is 2, which is equal to 32. So 32, let's say feet, whatever, feet a second. Yeah, 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 yeah. Feet a second. Okay, great. This is average speed because you're taking it from a point and interval 0 and 2. You're going to find the average speed between these 2 points of distance and time. But what if I were to ask you, what was the instantaneous speed at 2 seconds? What am I asking you? Well, I'm asking you at 0.2 seconds, not between these 2 points, but at 0.2 seconds. 2 seconds into it, what was its speed? What was the speed of the rock? Not what was the average speed between this point and this point, but what was the instantaneous speed? Like of the rock. How fast was it going at 2 seconds? Not how fast was it going over the whole interval on average. Okay, to find that, we could say, well, to try to find that, we could say, well, if we want to find out 2 seconds, we can take the average speed. We could take the average speed of 2 seconds plus a little increment. As in, if I were to, I could say, we could find at 16, 2 plus h over minus 16 at 2, square, over h, because it'll just be, because it would just be this 2 plus h minus 2, which is just h. So what this is basically saying we're going to take an interval. We're going to find the average speed of an interval of something, of a point that is a little bit above 2 minus that original 2. Now, this doesn't get us the actual instantaneous speed at 2, but it does help us look at what's going on around 2. If we wanted to find the actual instantaneous speed of 2, we would have to keep trying to find like intervals that are closer and closer to 0, because we want to have the least amount of change between 2 and minus 2. Like we'd have to keep going from like 0.5 plus 0.5 where h is 0.5, and then plus 0.05 or 1. I don't know why I'm using 5, but it's 5, or plus make h 0.001, where we try to make it smaller and smaller so that we're able to get instantaneous speed. Now, this doesn't give us the actual instantaneous speed, but it gets us like a small approximation. Because with a small increment to that x, to that 2, minus that x, minus the 2, over that small increment, we get an approximation. Now, but we can't get the actual one again because you would have to make h 0 and divided by 0 is equal to undefined. Now, if we were to simplify this, we could say, here, if we were to simplify this, this would be 416 times 4 was 64. So I'm going to write this up here. I'm going to erase all this. Um, 664. This would become 4 plus 4h plus h squared. Wait, give me a second. So this part would become 16 times 4 plus 4h plus h squared over square. Oh, well, no, that wouldn't be squared. I just did the squaring. Plus 64, because 16 times 4 is 64 over h. And then this would then become, if we were to distribute it out, it would become 64 plus 64. Well, actually, but these two, oh, this is minus, this is minus. These two would cancel out, so we can just erase this. So this would just become 64h plus 16h squared over, oops, h. Dude, I'm writing this awfully. This is terrible. And then this cancel out with this, and this will also cancel out with this. So it would be 64 plus 16h, because it was h squared. Now, if we are to assume that we're getting closer and closer to 0 whenever we're approximating h, whenever we're approximating this speed at 2, then h is getting closer and closer to 0, then that means that 16 is going to be getting closer and closer to 0. So we can ignore the 16, and it essentially becomes 64 feet per second. And this would be the instantaneous speed, or the approximation to the instantaneous speed. So yes, instantaneous speed is the speed at a point, which we were showing by measuring it over an interval, a small interval that's getting smaller and smaller and smaller, closer to 0. And average speed is speed over an interval, but the instantaneous speed is speed at that point. And this is how we were doing it algebraically. All right, seems cool.